So in this video, we're going to cover all the graphing questions from 2014's Applied EQAO. And you can go on the website, the EQAO website, and you can download the test from 2014's Applied. So this question is saying 5 students plot their arm span and height on the graph below. Which of these describes one of these 5 students? So all you need to do is look at your options that they gave you and try to match it up with the points on the graph. So this one says height is 166 centimeters and arm span is 162. So if I go to 166 centimeters, to be about here, and I go to 162, there's nothing here. So I know that one is not true. Height is 170 centimeters and arm span is 164. So this one I could see matches up. So I know B is my answer. Each month, Alex's cell phone plan costs $15 plus 10 cents per minute. As soon as you see that, you should know that it's a partial variation. Because you know, even if Alex does not spend any time on his phone, he's paying $15 a month right away. So at x equals 0, y is 15. So I know it's not this one, and I know it's not this one. This one starts here, and this one starts here. Another piece of information is he spends 10 cents per minute of use, which means the more time he spends on the phone, the more money he spends. So I know my graph is increasing. Okay, which means I know it's D, and it cannot be C, because C means he's paying $15 regardless of how much time he spends on his phone. So this one is asking which of the following best represents the trend. So whenever you see trend, it's talking about the pattern in the information or the line of best fit. So can you draw a line or a curve of best fit for this information? A line that starts at 0, 10 and ends at 1.50. So it'll start here and go down this way. It's not hitting any points. It's not really representing the data, so it cannot be A. A line that starts at 0, 0 and ends at 1.612. Also, not hitting any points and not representing the data. It's actually increasing while the data is decreasing. A curve that starts at 0, 10 and ends at 1.50. Okay, so it doesn't hit all the points, but it hits most of the points, and it gives you an idea of what's happening in the graph. And D, a curve that starts at 0, 0 and ends at 1.612, going the opposite direction of the data, so it cannot be that one. It would be C. Okay. This one is a little tricky because it wants to know what has a linear relationship between the number of squares and the term. You need to know what to look for. So linear would mean a straight line if you had a graph. It would look like this, or like this. You can also have a partial variation. If you had a table of values, the first differences would be the same. And this right here means with each term, you're going to increase by the same amount. So if I was going to go this way, from term 1 to term 2, I increased by 2. From term 2 to term 3, I increased by 2. And from term 3 to term 4, I increased by 2 again. Over here, I increased by 1. I increased by 2. So I know this one is not linear because I'm not increasing by the same amount for each term. And same with C and D. So that means A is my answer. If I had a table of values, let's say term 1, I could see that my differences are the same on both sides. This question is asking us for the rate of change, which means we need to calculate the slope. So I can go onto my graph and pick 2 points. Here's one. I always look for a point that's exact, so there's no decimals. So one point I have, remembering that this is x and this is y, would be 6 and 1000 and 0 and 100. And if I do this, I'll get 1000 take away 100, 6 take away 0, 900 over 6, which will give me $150. And you would get the same answer if you drew the triangle and you calculated your rise. And you run. This question is telling us the temperature outside at 6 a.m. is 4 degrees Celsius and it rises by 1.5 degrees Celsius every hour. I want you to complete the table. So this, you need to also pay attention to this part. I know from 1 to 0, that's 1 hour. From 4 to 1 is 3 hours. And from 4 to 6 is 2 hours. And that's very important because it's easy to go up by ones on this side, to assume it's going up by ones, and to continue adding 1.5 to this column. So here I went up 1 hour from 0 to 1, so I know it's 5.5. From 1 o'clock, or from 1 hour after 6 to 4 hours, that's 3 hours. So 3 times 1.5 is equal to 4.5. 4.5 plus 5.5 will give me 10. From 4 to 6, that's 2 hours, which means I'm adding 3 degrees. Okay, and it's very easy to get this mixed up and just to go from 4 to 5.5 to 7 to 8.5. You need to pay attention to how many hours you're increasing by. Okay, so here's my scale. There's enough length in the y-axis to go up by 1, so I just did that, and now we're just going to graph this. It's going to try to make it as accurate as possible with the pen I'm using. So 0 and 4. Our next point was 1 and 5.5 there. Our next point was 4 and 10. And then 6 and 13. Okay. Well, if I wanted to draw my line, I would go something like this. So this question is telling us that a hot air balloon, a green one, is rising at a constant rate, which means it's linear, so it should be a straight line, and it's going to be the same throughout the whole flight. A blue hot air balloon rises twice the rate of the green balloon. Determine the rates per meter at which the blue balloon is rising. So the first thing I want to do in order to get the blue hot air balloon's rate is to determine the green hot air balloon. And I need to get 2 points. I could see that my time is X and my height is Y, which means I can make 2 points out of this. Okay, so if I take X is my time, 2 minutes, and my height is 30, and this one, 6 and 75. I can do y2 take away y1, x2 take away x1. It doesn't matter which one is 2 and which one is 1, as long as you keep them in the same order. So 75 take away 30 over 6 take away 2 will give me 45 over 4 will give me 11.25 meters per minute. And this is the green. This means the blue will be 22.5. Okay. Another way you can solve this question is you could use the grid. So I can go to 2 minutes and 30 meters, and I can plot that for the green. And I can go to 6 minutes and 75 meters and plot that for the green as well. Because I know my blue is rising at twice the rate, my blue will be twice as high. So if my green is at 30 at 2 minutes, my blue will be at 60. And if my green is at 75 at 6 minutes, my blue will be at 150. And then I can draw my triangle for the blue dots, because I don't need the green anymore. And I can calculate my rise over run. From 6 to 2 is 4. From 150 to 60, that's 90. 90 over 4 is equal to 22.5. Meters per minute. Okay, and I could say, therefore, the blue balloon is rising This question gives us Liam's information in a graph, but Tiana's information in text. And it tells us Tiana's total charge is made up of a base fee of $40 and $10 an hour of tutoring. It wants to know if they both start tutoring at the same time one day and they both spend the same amount of time tutoring but get paid the same, how many hours did they spend? So at what point do both charges equal the same amount for the same amount of time? So if we were to draw Tiana's graph, the line, where do the two lines intersect? So let's draw this. So it starts, we see there's a base fee of $40, which means when x is equal to 0, y is equal to 40. So I'm going to draw that right there. $10 per hour. So at 1 hour, I'm going to go up $10. And you can see you're going 2 across and 1 up. Right here, I could see my lines meet. I was going to draw my line, it would look something like this. So where do my lines intersect? Right here. at x is equal to 4. So I can put Liam and Tiana each spent 4 hours tutoring.